Okay, good. That helps. All right, so our talk for today is an end-to-end demo of the power of the Lakehouse with Azure and Databricks. What we will discuss? Well, the Lakehouse is a new concept, a data architecture, which creates a reliable and unified source of data. And it's built on top of a data lake. So yeah, it's something new. And why are we speaking about this? Because I see that many organizations want to be data-driven, yes, but being data-driven is hard, and especially because we need data to be accurate. And we also want to combine more data sources to make our analysis. And I think that learning about Lakehouse within Azure is an opportunity for new projects or maybe for some new career steps if some of you might be looking into that, because I really think that this is a hot topic, and I see from my company that we have positions and the market itself is very open to hiring more people with these skills. So very nice to meet you. I am Bernardo. I was born in Brazil. My city sounds like Uruguay because it's rear the side of Uruguay. I did electrical engineering in Brazil. I worked as a data consultancy company in Brazil. Currently, I work at Jumbo, the second biggest supermarket in the Netherlands, and I'm also a Databricks teacher independently. All right. You will find me teaching, but also doing CrossFit. That's my favorite sport, but this is what I like to do. I really like to present about this and teach other people, help them get their career running. But you will also find me on YouTube from Jumbo because we have a video about Databricks and I am the guy that speaks. So yeah, we have a video on YouTube if you guys want to check later. Yeah, that's the video. But let's start with the agenda for today. I'm trying to be direct, so we only have two topics, a quick introduction and the demo. So let's do a comparison with the past. Before, let's say 1970s, 1980s, the technology out there was the data warehouses, and we had big databases that would gather or centralize the data, and it has been working very well. But there are some pitfalls and limitations. For example, is that a data warehouse has a proprietary format that comes to a vendor lock-in. So if you are Oracle, you are tied to Oracle. If you are a SQL Server or Azure SQL, you'll be tied to Azure SQL. But also, it has a limited growth in size and processing power. And also, it's not very well integrated with other data tools. Then we also have the data lakes, and let's do a comparison between these two. While the data warehouses have some really good aspects, such as relational databases, so it's very easy to work and create relationships between data sets. It also has ACID transactions. That's a guarantee that every process that you do will complete successfully or will fail completely, and you can have accuracy in your data. So that's basically what ACID transactions mean. And in a data warehouse, it's very easy to query and analyze data, but it is limited in storage capacity. On the other side, a data lake is a very scalable storage. It's very cheap also. But organizing information within a data lake can be complex, and also the governance and security is also very complex to have a data lake as your source of truth. But it has a problem that it's not reliable to be the single source of truth. Because in a data lake, you can have copies of your data. You don't have a rule to make sense on top of that data. And if we see what a data lake house is, it is a evolution of these technologies. So in the past, the data warehouse were very used for structured data, and pretty much we could get BI and reports out of it. Then the data lake came, especially because we want to work with different types of data. We scaled the volume of data, but then we end up having a kind of complexity here, because you might have a process to do the BI, you might have a different process to do data science, and also your machine learning models could be feeding data from other source. So we could end up with a mess here, so it becomes complex to handle. And the difference of a lakehouse is really this layer of metadata and governance, which will build on the top of a data lake. And from this layer, we can feed all of our data products. So what we will build is a lakehouse with Delta Lake. And the reason for that is to build this governance, this metadata layer. So about a data lakehouse, the main pros are the ability to use batch and streaming in the same architecture. So really, this is crucial if your company wants to have batch process, but also want to include a streaming process. And with a data lakehouse, we can use the same architecture for that. So the complexity becomes a little bit less because you don't have different ways to process the data. It is built on top of a data lake, so the storage is very scalable and we can really handle large volumes of data. The technology behind the Lakehouse is open source technology. For example, I use Delta Lake, which is from Spark, and the format of the data is also open source. And nowadays we have many integrations available for data products. So we can plug in our Lakehouse into a data product that will feed data or will consume data from our Lakehouse. And the cons, for example, is that it will need a query engine. What is a query engine? Is a tool that is able to process the data. And for example, here in Databricks, we can have the Databricks SQL that it will consume our Lakehouse and it will give an experience like a traditional warehouse. So it's very convenient to do so. But you will need a Spark cluster to process this data, and that's what's running here under the hood. So if you see the Delta Lake, which is the technology behind the Lakehouse, at least for Databricks, we can combine streaming and batch into the same tables because it's planned, it was built to work like this. And I will explain a little bit more about this evolution of the medallion architecture. So if you research about Lakehouse, you end up with this bronze, silver, and gold layers. Pretty much what I want to explain to you is that on this side, we have our sources. And then what we do the first ingestion, which is called bronze ingestion. And the idea here is that we have a copy of the data, 100% copy, but within the Delta format. And with this, later we can filter, clean, or augment our data. And we call that another layer. We call that the silver layer when we know that this is improving quality. And in the end, we have the gold layer. So the gold layer is where people and tools will consume our data. For example, this is a planned layer. So we go to the business and we ask our business, what do they need? So this layer is planned for serving the business. So if you see here, this is a very data engineering process of ingesting the data, cleaning the data, and here is preparing for serving that data. So complexity of, all right. So what drives the interest of companies to adopt data lakehouse? We see that integrating new data sources is a need. So the companies want to combine information. They want to have more deep analysis using data from different sources. We are also working with different data formats. So let's say you have an API that will feed your data in JSON, but you also have another system that is feeding your data into a CSV format. You can combine all of those different formats into your data lakehouse. But we also have a very growing volume of data. And of course, companies want to use or want to have those their machine learning workloads running smoothly, and the Databricks on top of a data lakehouse is a very convenient tool for that. And also data streaming. So if you want to analyze data in a shorter period, the streaming is a good way to solve that. So the benefits of using Databricks specifically, this is pretty much my point of view, but you can also hear the similar benefits from other people. But I find it very convenient to have a unified data platform. So really, finally, we can have one tool that will process the whole data landscape, and it will also serve the data, which is one of the biggest challenges. Also, it's very integrated with cloud tools, and I'll show how it works in Azure, but it works perfectly in the three clouds. Security is always a big issue, and Databricks has the same security as your cloud has. For example, if you use your personal access to log into your Teams, for example, you use the same user to access Databricks. So the security resides on your, let's say in my case, in my Microsoft user. Also, you can do governance within Databricks, so you can really restrict and protect how people are gonna access your data. It was built to be scalable. So if you have, let's say, not a very big volume of data, it is very convenient to use. But if your data is scale and you have a huge volume, you can just scale up your clusters and Databricks will handle it. So it was made to work with big data. And we have the convenience to scale up or down or even automatically to handle the data load. And also you can have an automation in your data process. So we can have our pipelines running smoothly. We can have triggers. We can have monitoring alerts. So it's end up being very convenient in that case also. So a quick tip, if you want to learn Databricks, but you are worried about the cost that it may have, and it can have high costs, I really recommend you to use the Databricks community. So here I have, like if you Google Databricks community, there is the real community, but there is a tool that is called Databricks community. And if you're gonna sign up, you're gonna see this screen. It will try to take you to your cloud provider. But if you look a little bit under here, you see the community edition. And this version is free to use. It has some limitations, especially in the processing power, but you can gain skills like your Spark skills, your SQL or Python skills. You can practice in there having no cost. I also recommend that you have a data lake storage because you need a data lake to really build the lake house. All right. So that's a quick tip. I will explain our demo for today, but let me just go ahead real quick. And I need to turn on my cluster. So we'll save some time. All right, my cluster is spinning up. Let me go back to the presentation here. All right, so what we're gonna present today is the end-to-end demo of a lakehouse. And of course, I'm bringing something more simple than you'll find, but if you understand the concepts here, I'm very happy, and I hope you get excited about this technology. So what we're gonna do is the 4 steps of data engineering. First, we will be extracting data from our source. And what is our source? It's a SQL database. It could be many SQL databases. And it's a scenario, a very realistic scenario, because within a company, within an organization, we may have, let's say, tens or even hundreds of data sources to consume. So we're gonna do that with Azure Data Factory. It's my preferred ingestion and orchestrating tool. We would then store the data in, I click here. We'll store the data in the data lake, the Azure Data Lake storage. Then we'll start our Databricks part, which will process the data. We'll do all the 3 layers, and then we'll serve this data to Power BI. So let's start with our demo on following this flow. So far, any question, guys? Are you guys familiar with it? Do you guys already use Azure? Are you guys already using Databricks? If you have any comment like that, I'll be happy to hear. All right, so let's start with this presentation. I will leave it here. Good, so we start from the source. Let's take a look in our source. So here in my Azure, I have a database that is here. So just to show you that I have a database on the cloud, and just let me log in. If I didn't forget the password, okay, I have to allow it because I'm somewhere else. Good, so here is my data source. All right, don't want to download it. I'm in the middle of something here. So I have some tables here. You see, it's 10 tables, not very much, but if I query something here, I will see some data. So that's our starting point. Here we have a relational database, very simple one. You can get started with that one very quickly in Azure. But yeah, this is our data source. So let's look back to this. Is Databricks gonna connect directly into the SQL database? No. We could, but we don't do it. What we use instead is Azure Data Factory. So let's go to Azure Data Factory. And well, where's my Azure Data Factory? Here, I will just quickly open it. I thought I had it, but it's very quick. I know how it works. I'll just also leave my Lakehouse open here. So here I have a pipeline, and this is the extraction from this database. So I have one activity for each table. So believe me, there are 10 activities here. So in my data lake, which is the place where I will store the data, I do have some folders here. And what I want to do now, let's say that someone came here and deleted the files. So it'd be like, wait, where did my files go? I don't know, but I can reload them. So I will just debug this or trigger this, and it will start running. And well, we can see how things are running here. We might have to wait a few seconds. And then once this is ready, in our data lake, we will see that a new folder will appear. Okay, that appeared. Happy with that. And some files appeared here also. So good, that's a good starting point. And quick explanation here, I prefer to use Parquet because it's very easy to process Parquet, but it could be a different format, although Parquet is very optimized to be used with Spark. Okay, we have some trouble here, but I'm not gonna dive into it. Might just trigger it again and see how it goes. But okay, so let's start the Databricks part. So very quickly, what I want to show is the 3 steps. If you look here, we just concluded this extracting data and storing. So now we will start processing this data because Databricks has an integration with the data lake that is called mounting the data lake. And once this connection is ready, what we can do with Databricks is that we can query our data lake. Okay, my cluster is on. Okay, so what I'm doing here, I'm looking in the data lake in that folder I showed you, and I'm looping to see which files are there. Okay, I see the same files here. That's good. So what I will do is very simple comments here let me just get this one real quick. So what I'm doing here, let me change address. So this is a very Spark read parquet command, a very simple one. And what it's doing here, address, it's looking in my data lake. Why are you not finding it? Okay, capital A, it's very sensitive. All right, so here, if I show you the content here, I can see that I have a table that's called a Spark data frame. And I see that this file here in my data lake can be processed within Databricks using Spark. So what I will do, I'll save this as a data frame, and then I can do some Python here to clean the data, process it. I can even create a temp view and use SQL. But what I want to show you is that I already prepared a function here that will read the data, but it's taking a parameter, which is the name of the file. I'm adding a timestamp, so that's a ingestion timestamp that I called bronze ingestion. So I'm adding a column here. And then this is very important. This one here makes the difference. So I'm saving my data in the Delta format, and I'm saving it as a table in Databricks. And I do have a database with this name here, and I'm creating a table for each file. So when I run this, I will see that it will start processing this data. So this is in Portuguese, but it means executing table. And after it runs, it should not take too long. We will have here in the Databricks part, we will have some databases. They appear here in the data. And this is a good thing about the Lakehouse, is that if I set up my Databricks correctly and I process my data and store it in the Delta format, I will have something like this, which is some databases and some tables, just like I would have in a relational database. And I can see some data here. So I can see the columns, I can see some example data, I can see the history of all the activity that happened in this table. So just like I would have in a normal database, but it gets more convenient when I can use SQL to do my data processing. For example, here, I'm querying a table called customer address from this database, and this is the result that I get. I could do somewhere, I could change column names, just like we would do in a SQL database. But I can also do that in Python. So for example, here, I'm selecting in a SQL statement But here I'm using Spark or PySpark to query the same table. So that's very convenient. So our bronze layer is done. Let's look back here to the silver layer, and I'll show you a very simple way to do the silver layer. So here I have this query. Let me just comment this part. So if I do a select like this, what's happening is that I'm checking this table, customer, from this database. And here with this select, I'm changing some column names. I could change some data types. I could also add another timestamp, which is the silver ingestion, which is very convenient to have. And here, when I run this, I can see how my data is looking. So let's say, well, there is an underline here, an underscore. Let's take that out. Okay, we took it out. How is it looking? Yeah, it's looking better. How about we store it as a new table? And with a comment like this, we can create a new table in another database. So what we are doing here is improving quality. So we are getting the data from bronze and we are storing into the silver layer. So here, with this comment, when I run it, it will get the same result here and store as this table. So good. What I could do, I should do one for each table, and I did it here. So I have, for each table, I have its own query because it has to be customized. We have different columns, we have different scenarios. And for example, here, a very simple way to clean this data would be with a where clause. And I'm just saying I don't want any product category which is 0 or which is null, just clean that. And I'm storing it in the silver database with the same name. I could also change the name here. You see this has not an underscore, but here I decided to put an underscore. And with that, I'm creating a new table. I'm enhancing my data. And again, if I check my data explorer here in the silver layer, I can see the data and, for example, product category, I can see that some column names are changed, and even in my data, I won't have any category, product category that is null. Should disappear here. Let me see. All right, don't want to debug that too much. Okay, different than 0 or is not null. All right, let me see. Well, I'm not gonna dive into this, but I should, let's say if I take this out, might be that the data will update here. Maybe I'm not looking for the same column. I'm not gonna worry too much about it. But yeah, that's a simple way to process the data in SQL. And last, let's say that we want to prepare some queries for the business. For example, something I really like to do, and I do that a lot in my work, is that I query the tables. Well, that's product. And then we also have some sales order header, some sales order detail. I know I have to join them. So I like to look for the columns that I will join them on. For example, here I can see that I have the same column in this one. So when I join them, I know which column to look for. And here I have a query that is joining all the data. So I have sales order detail, I'm joining with the header and then with the product, and I'm selecting the columns that matter for me. What I can do, I will query this and I can see the result. So here I can see how my data is looking. I'll see if I have to change some column name, maybe do some column types. So it's very convenient to work this way. And if I'm happy with this, I can create a table here. I'm calling this fact sales product and I'm saving in the gold layer. again with this command here, which creates a table as this selection. So if I run this, it will store here. All right. And I do have a small demo here to show you the Power BI part. So let me first comment this part. So again, I'm just recreating this table with this query here. And it worked. All right, so let's go to the last part. And I'm trying to be very direct here. Let's serve this data. So usually Power BI would, for example, Power BI or any BI tool would need to connect directly to the database. That's what we are used to. And also some companies try to do this, try to replicate the data in another database so they can connect the BI tool. What I'm showing you guys here is that we can connect Power BI directly to Databricks. And I will explain to you why this is very convenient to do. Do you remember that I told you that we need a query engine? What is a query engine? It's a processing tool that can read the data in the Delta format, because the Delta format, it has some metadata on it. So you need some intelligence to read this data, to make sense out of this data. And just to show you what I mean by that, every time I created a table like this, under the hood, what happened is that here in my data lake, I have, so this is Delta tables, by the way. This is a database and each folder is a table. So if I open a folder, I will see some files. Well, that's weird, but I have this Delta log. This Delta log, if we open it and read, it is making sense out of this data. So what can happen, let's say that we have old data here and we put more data into our table, it will create a new file here. And in this Delta log, it will say that you should only read this file. So in order for us to read the data, we need to be able to read Delta. So that means that we need a query engine. So the query engine is the thing that will process the data. So here in Databricks, fortunately, we have this SQL part. So in the SQL part, which is made for data analysts, we do have the same experience as we would have in a normal database. For example, I will just turn on my engine. This is my query engine. So it's called a SQL warehouse to make us very confused, because I was just speaking what a warehouse and a lakehouse is. But yeah, this is the name. So what this does is, this is the engine. And with this engine, I can come and query my data. So let me take a look in the data that I have. And here I will see my Hive Metastore, which has my databases. And here I can check my data. I can create a query with it. I can create some dashboard. So I can do some data analysis within Databricks SQL. But our demo will go to Power BI. And how we do that? In Power BI, we will establish a connection with Databricks. We will, of course, pass some credentials. We can use our own Azure user or our Microsoft user to log in or to authenticate. So that's possible. So let's say that my team gave me access to consume some data. If I log in to Power BI with my credentials, I will also log into Databricks with my credentials and I'll be able to consume the data. So here I have Power BI open, and what I'll show you is the following. So, okay, this bar is, so you see a graph? Are you guys seeing that graph? I'll just update my data here. And I am connected to Databricks. So I'm refreshing my data and it's going to Databricks and querying it. So, okay, what weird message. I'm glad that the message is in Portuguese, so you don't know what is happening. Let me see. So it's connecting, it's waiting for the, okay, connection worked. So what do you see here? So let's do a very, very quick analysis. It's not our goal here to dive into this data, but what I'm seeing is that I have this product that is selling the most, this Turing 1000 Blue. It's really selling the most. So let's say that something changed in the data. So our data engineers decided that we are not gonna process this product anymore. So here in our Databricks, we go and change the data. So what happened is that we just did a change in our data lake. In our Lakehouse, which resides in a data lake. Usually, this could be a trouble already, because if we are restoring this data or replicating this data in a database, a normal database or an external database, we would have to do this process again. We would have to update the information there. The advantage here is that Power BI is looking at the same data. So if I query this table here, if I query inside Databricks and I try, well, that's obvious. If I do a SQL here, select star from, and I query it, well, I can see the data. But if I do this where here, and I actually, and I try to, well, search for this data, I won't have any results because I changed the name, by the way. So product name, it's called name product. So I should just change here quickly. So if I try to query this data, I won't find anything because I just deleted here. I just filtered it. And what will happen is that we don't have to do anything else for our Power BI to be up to date. We just have to go into Power BI, if I find it. So you see, it's still here. Why it's still here? Because I didn't refresh. So let me refresh it, and this line here will go away. Otherwise, I just finished the presentation. Will it go away? Is it? So it's updating, it's querying the data again. And, oh, okay, it went away. So what happened is that I just did a small change here in my data lakehouse, and Power BI is consuming that data as it is. So if I have, let's say, a streaming flow that is constantly updating our tables, and we have a Power BI app that is consuming that data and refreshing accordingly, our data analysis will be up to date. So that was a very quick end-to-end process, just to show how this can happen automatically. If we go to Data Factory, which is our ingestion and orchestration tool, here I have the pipeline that will extract the data from the source. I also have a pipeline that will trigger, if I run it, it will trigger those notebooks I just showed you, the bronze, silver, and gold. So I can trigger them from here, bronze, silver, and gold. But I can also combine things. So if I use this pipeline here, I will have the ingestion process, and once that's finished, then I can trigger my Databricks part. So let's say I want to update my data by hour, then I can make a trigger for this to run every hour. So that's how we can orchestrate things within Azure Data Factory, but the real big thing is that everything here is integrated. So, well, that's that was my demo for today. Especially this part, guys, I think that's very, very important. And the very last thing, and you guys can prepare your questions already. This serving of data here, it can be low cost, or it can have the cost reduced, because this cluster or this query engine that we have in Databricks, in this case here, this cluster here, it's a serverless option. And with the serverless option, what we can do is that we can stop it and it will sleep. So we don't have any cost by having this. As it is, we don't have any cost. But I'll show something. Back then, we didn't have serverless option, so we would need to wait 5 or 10 minutes for it to start up. So if you were in Power BI and you tried to do an update, it would not be able to update, because it would have to wait for the cluster to wake up and then give you the data. But with this option, the serverless option, it will start up in seconds. So you saw it was stopped. So I will stop it again. It's off. And now I'll cancel this. And if I ask Power BI to refresh, it will automatically start up the cluster. So it already started, and that happens in seconds, and it turns off automatically after 5 minutes. So let's say your team is consuming data, it's on, your team stopped, or Power BI is not refreshing, it will shut off, and we can save some costs with that. So good. Let me just stop it again, and I know it's off, but if I hit refresh, it will start off automatically. So good. Well, that's it, what I had to present. I mean, plug in the power. Okay, I have power. What do you guys think? Let me know the questions, and let me know if the presentation was clear for you. If you already saw like a end-to-end demo within Azure, combining these tools. Let's see if you guys have other questions. And while you prepare it, I just want to have a final message here. Well, I just introduced a concept of a data architecture that has an increasing demand in the market. You can strengthen your skills as a data engineer, and you can also make personal projects with architectures like this. And well, now we go for the questions. And while you prepare that, I do want to say, if you guys are planning on getting certified by Databricks, I do have some teaching lessons about it. I first did in Portuguese, but I can also help in English. So if you have the plan to get certified, pass in the data engineering test, I will leave a form to Victoria so she can share with you. And yeah, that was it. So let's go for the questions.